Welcome back to Geometry, Chapter 9, Section 2. And what we're talking about is we've been talking about right triangles, and now we're going to talk about what we always talk about with right triangles, the Pythagorean Theorem. And I just have to tell you, I really like this chapter. I think it's pretty easy for kids. Most of you have had the Pythagorean Theorem at some point in your life before, and I think it's really interesting once we get to the trig part of it. So I hope you like it too. I think it's really fun. All right. What is the Pythagorean Theorem? One time, a long time ago, I saw an article where there was a movement to rename the Pythagorean Theorem because they said that the name scared kids off, that to name it something else, like the Bill Theorem or something like that. But that never happened. So don't be scared off from the big name. It was just an old Greek guy who figured it out. Mighty smart fella. Thousands of years ago. But a little trivia on this is, you know how we have proofs where you prove everything in math. Well, there are things that are discovered, but they haven't proven it yet. So Pythagoras figured it out, you know, over 2,000 years ago, but no one had figured out how to write the proof for it until our president, James A. Garfield, you know, like being president wasn't enough. Oh no, he's the one who wrote the proof finally and figured it out and discovered it for the Pythagorean Theorem. So he was a really interesting guy. He could write Latin and Greek with both of his hands at the same time while thinking it in English. And then he got assassinated. Really interesting fellow if you ever read about him. But anyway, he's the one who wrote the proof for it. Go Garfield. Alright, so this is the Pythagorean Theorem. A squared plus b squared equals c squared. It's with right triangles, and it doesn't matter which one's a or b, but c has to be the hypotenuse. It has to be the longest one. So these are called the legs, as it doesn't really matter which one, but the c has to be the hypotenuse. So here's an example. If a is 3 and b is 4, then c would be 5, because 3 squared is 9, and 4 squared is 16, and 5 squared is 25, and 9 plus 16 is 25. So I'll show you how to solve for it down here, but that's just showing you that this relationship, 3, 4, 5, it does work with the Pythagorean Theorem. Now, if you end up with whole numbers, integers actually, but you can think of them like whole numbers, for the sides, then it's called a Pythagorean triplet. So, but if they're decimals, then they're not. So this one that triangle is a Pythagorean triplet. Now, here's the example problem. Sometimes they turn them different ways, and they do that on the SAT, the ACT, and this college entrance exam, so watch out for it. They'll try to turn the triangles around and be tricky. But here's one. So what you have to do first is figure out what is the hypotenuse, and it's this one, it's the x. So if I can solve for x, I can say this leg, 12 squared, plus this leg, 5 squared, equals the hypotenuse squared. 12 squared is 144, 5 squared is 25. Add them together, you get 169. Why is x not alone? Because it's squared. What's the opposite? Square rooted. What I do to one side, I do to the other. How do you get something out from underneath a radical? You look for twins. And 169 is 13 times 13. So they're in jail at the Arkham Asylum for the criminally insane in Batman. And how one of them's going to get out is that he's going to kill his twin and dissolve him in acid. I know it's violent, but it's the criminally insane. So then he's going to hop in the body bag, play dead, and get out of jail. So one goes away and one gets out. So the square root of 169 equals 13, which means this side that we didn't know is 13. Is it a triplet? Yes, those are whole numbers. Okay, let's try this one. We've got 7, 14x. Which one is the hypotenuse? Always ask yourself first, and it's 14. So we're going to say a is 7, b is our unknown leg, and c is our hypotenuse, 14. 7 squared is 49, 14 squared is 196. Why is x not alone? Well, two things. It's squared and it's got a 49. we always work from the outside in, so we're going to get rid of the 49 first by doing the opposite. What's the opposite of that? Plus 49, minus 49. What you do to one side, you do to the other. Those cancel out. 196 minus 49 is 147, and we bring down the x squared and the equals because we didn't mess with them. Now, so y is x non-line, it's squared. What's the opposite square root? What I do to one side, I do to the other. So I'm looking for twins in 147. So 147 is 49 times 3, and 49 is 7 times 7. So 3 stays in jail. He doesn't have a twin. 7 gets killed, and this 7 gets out. Whoop, whoop. So x is equal to 7 times the square root of 3. Now, a lot of times you need to put it on your calculator and see kind of what that is in real life, what it is approximately to, but this is actually a more correct answer. Okay, so here we have another one. This one, it's got, both of these are 7. So that means this is an isosceles right triangle, and they told us that the hypotenuse was 10, but because it is isosceles, we know that this height goes right down the middle, chopping that 10 into 5 and 5. And we want to find the height so we can get the area. So we're going to use one of these triangles. We'll use that one. And we can say leg x squared plus leg 5 squared equals hypotenuse 7 squared. And so x squared plus 25 equals 49, because x has got a 25 here and an x squared, we work from the outside in. What's the opposite of plus 25? Minus 25. What I do to one side, I do to the other. Those cancel out. 49 minus 25 is 24. X squared equals 24. Y is x, not alone, it's being squared. What's the opposite? Square rooted. What I do to one side, I do to the other. 24 is 6 times 4. 4 is 2 times 2. There's my twins. This one gets killed, that one gets out, right there. 2 and 3 don't have a twin. They get multiplied back together or in jail right there, the 6. Okay? So this is the height. It's 2 times the square root of 6 right here, and we can put it in our formula for area of a triangle. It's 1/2 base times height. So it is equal to 1/2 times the base of this whole triangle is 10. And the height of this triangle is 2 times the square root of 6. Put it all in your calculator and you'll get the area is about equal to, I think, 24.5. That might not be rounded. That might be exact. I'd have to do it. Now, your calculator, especially if you've had me before, has programs that can do this. Mine has 2. The one is called Pythagorean, and it will find the C. It will solve for c squared. The other one is called find leg, and it will solve for a or b squared. I would say you need to get both. And so if you don't have these on your calculator and you live near me, come over, I've got cables, I'll give it to you. If you don't live near me, then you can get these programs. They're out there. You can get them off the TI website. You can write them yourself. You might have to do a little research. You can call around to all your friends who have calculators too and see what programs they have. And you just need the cables, you stick them together, and I can even make you a video on how to get those programs if you don't know how. Alright, so you need to have the programs because, like I've told you before, your calculator does not get nervous. Your calculator does not stay up too late playing Animal Crossing. Your calculator does not eat too much pizza and its stomach hurt. So when you're taking these big tests like the SAT, the ACT, and the college entrance exams, or testing college, you need to use your calculator a lot because it will help you. You can use it for checking, you can use it for doing work, and the better you are at it, the better you're going to do in those big situations. Alright, math is great, come back, and we're going to get to learn trig. Woohoo! It'll be fun.